All right, good morning and happy Thursday. It's 6:24 in the AM and it is June 15th. Plan on doing the LeetCode Daily Challenge for today. Let's see. Who's that? Okay, here we go. June 15th. It's time to shine. Maximum level sum binary tree. Okay, so we should be able to do this in either depth first search or breadth first search. I solved this about 4 years ago. Okay, cool. So we'll plan on doing this in all the languages that I've been coding in. That is, I'll do Kotlin, JavaScript, Python 3, Rust, and C++. So here we go. Let's do, and per depth, can do, yeah, either depth first search or breadth first search. Let's just do both, right? Right, okay. So let's just do DFS first. Let's go, node equals root. Return go, let's do go, and then return the maximum as the best, right? So I use a map just to store each of these per level. Okay, let me just write this game plan. Use a map M to store each level's sum. Oops, and then return max, right? So that's game plan. Return the maximum m dot values. Oops. Okay, and then if not node, then return. Otherwise, keep track of the depth. Okay, m sub depth plus equals node dot value. Go node dot left, depth plus one, go node dot right, depth plus one. All right, something like that. Two and then two. Uh-oh, seven. Oh, the level. This is starting at one. Okay. Okay, I didn't quite read that right. So we actually want the maximum depth. So how do we express that? The maximum ID plus one. Okay. Oops. Key and then value. Key is the depth. So we want it by value, right? Total at each depth. Something like that. So it should, oh, plus one, right? Plus one. Maximum. Okay, that looks good. Ah, come on. All right, let's submit this, see what happens. It is 6:28 in the AM and has about 4 minutes for wrong answer. Oops. What happened? Input is this. Output's 3, but expect 1. Let's see what we got. Output's 3, but expect 1. Oh, do we break ties based on minimum? Smallest level, yes. We break ties based on minimum. Okay, so I didn't really read that very closely. Okay, so note, we break ties via min. Oh, yeah. Okay, so that I could hack it, just do negative depth -1 and negate it. I think that works. It's kind of ugly. Yeah, okay, so that works. Oh, come on. Okay. All right, +1 bug, 6:30. Solved at 6:30. So about 6 minutes for the implementation. And Python 3, which is accepted. Yay. +1 bug. Okay, I mean, we could do BFS as well. I mean, this is pretty simple, though. Well, I said I'd do both, so might as well just be a man of my word, right? Okay, the deck. 1 def at a time. Based on the length of the queue. Oops. Turn the same thing, right? That's good. But similarly, I could do this as well, right? Or next, and go top left, go top right, go next. Oops. This should be fine. That works too, right? Kind of like this one, though. This works, right? Okay, so that's cool. Let's see what it came with. I came up with like 4 years ago. One C++ solution. Okay. So just basically a DFS without the lambda. Actually, what did I return in the end here? Distance. Oh, interesting. Yeah, that works out pretty good actually. Just using a vector. You have to assume the max element returns the first one though, right? The first instance. This vector is huge though. Okay, well, let's do that. I mean, that's a little bit cleaner, right? I really like the way that I did that compared to this return statement is just ugly. Right, so instead of a counter, I just do a depth array, an array of depths, right? So if length of A is equal to the depth, then we'll push it back, right? A dot pinned 0 for that depth. Actually, let's do this. Yeah, let's do that. And then A sub depth, let's equals node dot value. Index of the maximum. A dot index of maximum of A plus 1. Index of, oh, it's just index. Looks good. Let's make sure the one I missed is cool too. Oops, let's see. Okay, here we go. Make sure there's no regressions. Okay, cool. Pretty decent solution. All right, let's update this. Few solutions. Perform DFS tracking each depth in an array A. Then return the one based index of the maximum value of A. All right, Kotlin script. On 3 rest C++. Okay, so here's Python 3, right? That's cool. Okay, I'll do this in C++. 6:37 a.m. and it is time to shine. CNBI and vector of integers. BI, an array of depths. Fun. Oops. Fun will be our function. Won't return anything. I'll take a tree node pointer and depth. Capture yourself in your own lambda so we can invoke ourselves. Turn distance from again to maximum element. Oops. To again. And it's 1 for one base index. Node return. Otherwise, do if a dot size is equal to the depth and a dot push back 0. A dot back plus equals value. Oops. Go goes left plus 1. Goes right. It's 1. Already. Uh-oh. Oops, yeah, I need to do root 0 for the default. Not the default parameters are not allowed in the lambdas here. Okay, so there we go. It looks good. 6:37 to 6:39 a.m. Uh-oh, 2 minutes. Wrong answer. What happened here? Something is missing. Let's see, let's grab these. Make sure there's no regressions once I actually fix this one. Okay, let's do the tree visualizer and see what's going on. -100, -200, 300. So what is the maximum element? Should be this last one, I suppose, then, right? At least negative. And huh. Well, let's do this. Copy, get up again. All right, we'll just print a. Oops. Flush the output. Okay. Let's see what we got here. Oh, oops, not a dot back, but a sub depth. Okay, well, that'll do it. And should be good. Okay, cool. All right. Minor typo / bug. Okay, I mean, that looks good. Pretty decent solution. Do JavaScript. 6:41 in the AM. Root a go. Oops. Node equals root def 0. Oh. And return. And see the index of the maximum value. A dot index of math.max a +1, one base index, base case, if length is equal to the depth, then a dot push 0, a sub depth, oops, depth plus equals value, go dot left, depth +1, go no dot right, depth +1. Something like that. Looks good. 6:41 to 6:42. Oops, not an hour. 6:42. About 1 minute. 1 minute for the implementation. Implementation in JavaScript, which is accepted. Yay. Hey, that's cool. Okay, I'll do Kotlin and then Rust, and we'll call it a day. Kotlin. Mutable list of integers. 0. It's fun to go. Anything. Let's go. Return a sub max index of. Oops. There we go. Okay. And if node is null, otherwise, if a dot size equal to depth, a dot add 0, a sub depth equals node value. O nose left. Plus one. It's right. Oops. Plus one. Okay, something like that. Whoa. A sub A dot index of A dot max. Index how's it negative 35? What the heck? What? Yeah. Len. Oops, A dot join to string. Choose the default commas, separator, delimiter. Let's see. Oh, oops. Plus one, right? I want the index of it, not right. Okay. Just totally confused myself. Okay, this looks good. That's cool, right? Where did my cursor go? Here we go. Submit that. It's cool. Okay, and then we'll do rest. Save the best for last here. Okie dokie. Type node. I'll just get rid of this thing because it's huge and ugly. Right, there's our type alias. Okay, and then F and go. Root is a node. That is I32. It's not going to return anything. Go root 0. If let sum node equals root, otherwise we'll do nothing. Let mute node equals node dot rows, row. Cool. And then if, let's see, I want to have the array, we'll pass as a reference. VI is a vector of I32s, mutable reference. Let mute A equals vector. Okay, pass in A as a mutable reference. If A's length equal def is the usize, A dot push 0, A sub depth equals node value. O A node dot left dot take def plus one. Go A node dot right take. Okay, something like that, and we'll submit it. Fix compile errors. Oops, there's the one right missing right there. Mismatched types. Oh, oops. And then we want to return the maximum depths, or the maximum value of A is index. Return the index of, let's see, rest vector. Let's look at the documentation. Let me find the index. Index. What is this? Index. Just indication of index of index. Subindex. Oh, okay. But I don't think that's what I want. Let's do this. Rust value or index of value and vector. Iter dot position dot unwrap. I see. Okay. A dot into iter dot position of the maximum value, right? I want the maximum value of A. Or is I 32? Okay, something like that. Max. Target will be A dot iter max unwrap object and location of that. Compare this with that. Oops. I will do the reference then, right? Left. Node dot. Oops. Left and right. Okay, that looks good. Big money won't, no whammies. Yay. Okay, there's rest. And there we have it. That's all she wrote. Form DFS tracking each depth in an array A. Then return the one base index of the maximum value of A. Right? Yeah, that sounds good. I wonder, let's see if we can clean this up a little bit, right? I mean, it's accepted, but I don't think I usually don't stop at accepted. I wonder if this would be quadratic. Or if it's even allowed. Maybe I borrow it too many times, I don't know. No, it seems like it's okay. I don't know what to do with the runtime. Yeah. Doesn't really adversely affect the runtime, so might as well just stick it on one line. All right, so yeah, there we go. I'll catch you all later.